Hello everyone, this is chapter 1, lesson 1.4. In this lesson today, we will be finding the greatest common factor of two numbers. We will be using two methods to solve this. Please make sure you write this down, copy this down. I'll say this again, we're going to be using two methods. First method is going to be the tic-tac-toe method. I call it tic-tac-toe, right? Tic-tac-toe. This method works like 99% of the time. And then the other method we're going to use is prime factorization. So we just did this in the last lesson, so it should be very familiar. Okay, so let's move forward and let's see if we can do some of these. All right, here we go. Make sure you copy this down. Number one, we're going to do some prime factorization, or actually tic-tac-toe method. We're going to start like this. So I'm going to draw my tic-tac-toe like this. I'm going to take my first number, I'm going to put it in here. I'm going to take my second number, I'm going to put it in here. And then in this box right here, what I'm trying to do is I want to find a number that can go into both 10 and 35. Well, so this is where like knowing our multiplication comes very in handy. And I'm thinking of a number. What number can go into 10 and 35? Well, I'm thinking the number 5. Okay, so let's see. How many times does 5 go into 10? It goes 2 times, so I'm going to write it right below. I'm going to ask the next question, how many times is 5 go into 35? It goes into there 7 times, okay? Now, the next part of this is I have to think, is there a number that can go into both 2 and 7? Is there a number that can go into both 2 and 7? There isn't. So if there is not a number that can go into both 2 and 7, all I got to do now is multiply straight down. So 5 times nothing, right? Because there's nothing here. There's no other number. That means our GCF for this question is going to be 5. Okay. So now this was called the tic-tac-toe method. We're going to try one other method, and this is the prime factorization one. So I'm going to erase this. So make sure you had this copied down. And we're going to do some factor trees. Remember, we did this in the last lesson. So we have 10 and 35. Rewrite the problem so you guys can have two examples. And let's see what two numbers will give me 10. We have 2 and 5. All right, so now I'm going to do a factor tree over here. And let's see what numbers can give me 35. Well, I know 7 and 5. And honestly, that's about it, right? So now the next question is I need to find a number that they both have in common. So what do they have in common? They have this 5 in common, and they have this 5 in common. So the prime factorization for both of these would be just 5. Okay. Now, if they would have had like one more number, let's say 2 and 3, right? So then the next number they would have had in common would have been 2 and 2, right? Because they both had a 2. And if they both had a 2, then I would have to do 5 times 2, right? Because this one had a 5, this one had a 5 and a 2, and then I would multiply. It's going to make sense in the next one. We're going to try it again, but let's see if we can figure this out. We're going to start with the tic-tac-toe method, and then we're going to move on to the next method, okay? So here we go. Let's draw our tic-tac-toe. We're going to put in our first number over here, so that's 18. Put our second number over here, so that's 42. Now we got to think of a number that can go into 18 and 42. If you really know your multiplication and division, the bigger your number is, the faster you're going to get your answer. But if you don't know, you can start off small. So I'm going to start off with the number 2 because I know they're both even. So let's see, how many times does 2 go into 18? Well, I know 2 goes into 18 9 times. How many times does 2 go into 42? Well, that's going to be 2 times 21. If you don't know how to find that, you can divide. So we're going to divide 42 by 2. Let's see, how many times does 2 go into 4? It goes in there 2 times. 2 times 2 is 4. 4 minus 4 is 0. Let's bring down this 2. How many times does 2 go into 2? It goes in there 1 time. 2 times 1 is 2. We subtract that, we get 0. So we got 21, right? Now here's my next question. Is there a number that can go into both 9 and 21? Yes, there is. And that number is, what is it? 3. So how many times does 3 go into 9? Well, it goes in there 3 times. How many times does 3 go into 21? It goes into there 7 times. Now my next question is there a number that can go into both 3 and 7? Nope. So that means all I got to do is multiply straight down. 2 times 3 gives me 6. So we know our GCF for this question is 6. let's see if we can find another answer using the prime factorization method. So I'm going to erase all this. Here we go. Now let's do our factor trees, right? So rewrite this problem so we can do our factor trees. What two numbers give me 18? Well, let's try something different this time. We'll do 6 and 3. And then we're going to break down 6 into 2 and 3, right? Good. So now let's break down 42. 42 we have, let's say, 7 and 6. And then we're going to break down 6 into 2 and 3. Now my question is I want to find something. So if we draw a Venn diagram, okay? A Venn diagram, we want to find one number that they both have in common. Let's actually draw that a little bit bigger. So check this out. So I have this circle over here. I have this circle over here, and here in the middle, I want you to put both numbers that they have. So let's see. There's a 3 here. There's a 3 here. Then there's a 2 here, and then there's a 2 here. So that means they have a 2 and a 3 that are exactly the same. So all we got to do now is multiply these two numbers. So 2 times 3 gives me 6. So our GCF for this problem is 6. Let's try another one. Again, we're going to try the tic-tac-toe method first, and then we're going to do prime factorization. So here's my tic-tac-toe. We have 48. We have 120. Well, ladies and gentlemen, on these big numbers, honestly, there's no trick to figure it out. It's just a lot of practice and knowing your multiplication. So can you think of a number that can go into 48 and 120? I do. I'm thinking of the number 8, right? So let's see. 8 times 40, or so how many times does 8 go into 48? That's going to be 6 times. And here's my next question. How many times does 8 go into 120? Doesn't it look like a weird number? But what I did is I broke 120 into two numbers. I broke it into 80, and I broke it into 40. I know 8 goes into 80 how many times? 10 times. And I know 8 goes into 40 5 times. So these two together should give me 15. Let's just double check our work, make sure I did this right. So let's see. 8 times 5 is 40. Carry the 4. 8 times 1 is 8 plus 4 is 120. Good. So now let's try the next one. Is there a number that can go into 6 and 15? Yes, there is. That number is 3. So how many times does 3 go into 6? It's 2 times. How many times does 3 go into 15? That's 5 times. So now we just have to figure out a number that, there's no other number. So all we got to do now is multiply straight down, right? So let's multiply straight down. 8 times 3 is 24. So our GCF, greatest common factor, for this problem is 24. Make sure you're copying this down and answering these questions. It would be good if you can answer these questions before I write it down. This time, let's rewrite this, and this time we're going to do the factor trees. What numbers give me 48? Well, I know it's 8 and 6. What numbers give me 6? That's going to be 2 and 3. What numbers give me 8? That's going to be 4 and 2. And what numbers give me 4? That's going to be 2 and 2. All right, let's do 120. I know it's going to be 12 and 10, right? 12 times 10 is 120. 12 is going to be 6 and 2. 6 is going to be 2 and 3. And then 10 is going to be 5 and 2. So now let's see which numbers do they have in common. I'm going to highlight them, but you might be easier for you to circle them. So I have 1, 2, 1, 2. Okay. Now I have another 2. I have another 2. Now I have a 3 and a 3. Okay. And then I have, let's pick a different color. Got pink now. Oops. Now I have another 2 and another 2. And they have a 5 and a 2. So that's about it. So now I just got to multiply these numbers. So I have a 2, this 2, times this 2, times this 2, times this 3. Let's see what we get. 2 times 2 is 4. 4 times 2 is 8. And then 8 times 3 is 24. So our greatest common factor for this problem is 24. All right, let's try another one. It's question number 5. Let's see. Let's do just the tic-tac-toe method on this one. Okay. So we're going to put an 8 here. We're going to put a 12 here. Well, what number do you think can go into 8 and 12? I'm thinking 4. 4 goes into 8 twice. 4 goes into 12 3 times. I'm asking myself, is there a number that can go into 2 and 3? Nope. So all I got to do is multiply straight down. 4 times nothing is just 4. So our greatest common factor for this problem is 4. Let's try the next one. Looks like we got 3 more. This time I'm just going to do the prime factorization of these problems. So let's see, what number gives me 22? That's going to be 2 times 11. And what numbers give me 121? That's going to be 11 times 11, right? So what number do they both have in common? They both have an 11, so that means our greatest common factor for this problem is just 11. Let's try another one. Number 7. Let's try Tic-Tac-Toe Method. Let's see if it works. Remember I said Tic-Tac-Toe Method works 99% of the time. Doesn't work all the time. The other method, prime factorization, works all the time. Let's try it out. So we got 50 and 90. Is there a number that you can think of that can go into 50 and 90? I'm thinking 10. All right, so 10 goes into 50 5 times. 10 goes into 90 9 times. Can you think of a number that goes into 5 and 9? I can't. So let's just multiply straight down. 10 times nothing is 10. So our greatest common factor for this problem is 10. All right, let's try another one. This time let's do prime factorization. Let's draw a factor tree. What numbers give me 36? It's going to be 6 and 6. What numbers give me 6? That's going to be 2 and 3. And we have 2 and 3. Let's think of some numbers that give me 60. So we have, let's see, 10 and 6. We have 2 and 5. And what numbers give me 6? We have 2 and 3. All right, let's see what they have in common. There's 1, 2 over here, 1, 2 over here. So we're going to do our first one. It's 2 times. We have a 3 over here. We have a 3 over here. That's times 3. Let's see if there's one more. There's a 2 over here, and then there's 2 over here. So there we go. So now we just need to multiply this. 2 times 3 is 6. 6 times 2 is 12. So our answer for this problem is going to be 12. The greatest common factor for this problem is 12. All right, let's try another one. Looks like it's our last one for this problem. This one we're going to do Tic-Tac-Toe Method and the prime factorization. So let's do Tic-Tac-Toe. I got 45 over here, 75 over here. Excuse me, sorry. What number can go into 45 and 75? Well, I know they both end with a 5, so I'm going to divide by 5. 5 times 40, or sorry, 5 goes into 45 9 times. Well, let's see how many times does 5 go into 75. If you don't know, you can divide. 5 goes into 7 one time. 1 times 5 is 5, so 7 minus 5 is 2. Bring down that 5. 5 goes into 25. I know 5 times, so our answer is going to be 15. All right. My next question is there a number that can go into 9 and 15? Yep. That's going to be 3. Well, 3 goes into 9 3 times. 3 goes into 15 5 times. Now we just need to, oh, sorry. Let's see, is there a number that can go into 3 and 5? Nope. So if there's no number, all we need to do is multiply straight down. 5 times 3 is 15. So our GCF for this problem is 15. All right, let's try another one. Let's see what's up. This time we're going to do the prime factorization. So let's make our factor tree. What numbers give me 45? Well, I know it's 9 times 5. And the numbers that give me 9 are 3 and 3. All right, so those are prime. Let's do 75. I know 25 times 3. And then I know 5 times 5. All right, so let's see what numbers do they have in common. So they have a 3 and a 3. So I have 3 times. They have a 5 and a 5 times 5. And it looks like there's nothing left over. There's no more 3. There's no more 5. So all we got to do is multiply. 3 times 5 is going to give you 15. So our greatest common factor for this problem is 15. All right, ladies and gentlemen, we're going to practice a few more of these tomorrow. But I hope this kind of helped you out. And I'll see everybody later. Have a great night. Bye-bye.